And now it's lit up a little bit more. It was just having some issues with lighting so that you couldn't see it. Let's go from here. Number 4, it says there's a graph at the right, and it shows the position of a function of a car. So we're looking at a position graph. And it says answer these questions. So A is, what was the car's initial position? So when I look at the initial graph, I'm looking at time as 0. What do you see it as? The initial position, just looking off the graph. So do you see that it's 0? That's the initial position. Next, B. It says, what was the car going faster at A or at B? And what you're looking for is what is the slope is steeper. So when you look at A or you look at B, the car was going faster at A because it is a little bit steeper at A than it is at B, where B is a little flatter. So the steeper the graph, the faster it's going. Part C says, was the car speeding up or slowing down at B? Well, if I look at B, I want you to notice that you have to look really carefully. The slope of the position graph is just slightly decreasing, just slightly dipping down. So for part C, it is slowing down. And that's because at B, I want you to notice that there's just a slight dip, a slight going down. And it's hard to tell there. But when I'm looking at it, it's just going down just a little bit, and then it's going to come back up. Was the car speeding up? I did that one. D, what happened between C and D? So I want you to notice between C and D that it's a horizontal segment. And so what happened at C, or between C and D, is that the car stopped. And that's because there's no distance there. So when it's horizontal, it's not gaining distance at all. It's just horizontal, so that meant the car stopped. 5. A particle moves along a horizontal line with position function t cubed minus 3t squared. And then find different things from that. So I'm going to write down that position equation, t cubed minus 3t squared. And then we'll just start answering it one at a time. So this is a conceptual question, so things can be positive or negative. So find the particle's displacement between 0 and 5. So displacement means what position was it at the end, what position was it at the beginning of that interval, and just subtract the two positions. So in this case, plug 5 in, and you would get the answer 50. Plug 0 in, and you get 0. So when you do that, the position, the displacement, and that would be in centimeters. Make sure the unit's there. Part B. Find the particle's velocity. So to find the velocity, we're going to take the derivative. So that's 3t squared. Subtract 6t from the position equation. And it says find it at 4 minutes. So we'll plug 4 in. And then if you plug 4 in, the answer is 24 into the velocity. And then we need units, and that's centimeters per minute. Part C. In part C, find the particle's acceleration. So again, we need to take the derivative of velocity. So from here, take the derivative, 2 times 3, 6t minus 6. That's the derivative. And then at 4, we're going to plug 4 in and get 18. Now, how do we write this properly? So velocity is centimeters per minute. Acceleration is centimeters per minute. Per minute. That's how you would write it. Or you would write it as centimeters per minute squared. Both are right. But that's how you write acceleration properly. We need to learn how to write position, velocity, and acceleration properly with the units. With practice, it'll be easier. D. At what time does the particle change direction? So a particle, we would look at the velocity, of it first. So when does it change direction? So take the velocity, and what we're going to do is we're going to make it equal to 0. When the velocity is equal to 0, the particle is stopped. And if it's going to change direction, it must conceptually stop before it changes direction. So we just want to know when the particle stopped, then we're going to look at the intervals that creates. So to solve this, we're going to factor out a 3t. We'd be left with t subtract 2, and then solve it. So the first factor gives me the answer 0. The second one gives me the answer 2. So I'm looking at 0 and 2. Now make sure this is conceptual, so time could be positive and negative. So on here, I'm going to create a velocity number line where these are the times, and I'm going to put the interval of 0 and 2 on. So into the velocity, what would happen if I plugged in a negative number? Would the answer be positive or negative? So plug in -1. Any negative number would do. And know that it would end up being a positive answer. Negative times a negative is positive, square negative. Negative time is going to give you a positive velocity. Plug in a number between 0 and 2 into the velocity. So the easiest number is obviously positive 1. So when you plug in positive 1, you actually get a negative velocity. Plug in any number bigger than 2, like 4 or 3, and you'll notice the answer is positive again. So what's happening with this particle in terms of direction? So I want you to know that in this interval, it's going to the right. In this interval, it's going to the left. And then in this interval, it's going to the right. So a positive means it's going to the right. Negative velocity, it's going to the left. And then positive again, it's going to the right. Now understanding this, the question is, at what time does the particle change direction? So now you can see when the sign changes, it changes direction. So at t equals 0, and this is in minutes, and t equals 2. So at 0 and 2 minutes, because of the sign change, right, left, then left, right, that's when it changes direction. All right, E. What is the total distance traveled by the particle between 0 and 5 minutes? Now, for total distance, that's different than displacement. For total distance, we have to understand the direction it went to the right and the direction it went to the left. So between 0 and 5, we need to recognize that it changes direction at 2. So we need to find the direction to the left, the distance covered to the right as well, from 0 to 5. So first, from 0 to 2, what distance to the left? So that's the first thing we're going to do. So where it ended and where it started, that's all the same direction, from 2 to 0. And you plug that into the placement, into x, 2 and 0, and then solve it. You can use your calculator if you like. So this gives me the answer -4, and this gives me the answer 0. Now, when we take that answer, we're going to do the absolute value of each one and add it all as positive distances. So, but this negative just tells me it went 4 centimeters to the left. Now, we're going to end at 5 to 2. So from 0 to 2, it went left. From 2 to 5, it went right. So it has to go in the same direction. We're just calculating that distance. So plug 5 into the equation, plug 2 into the equation. So when you plug 5 in, again, you get 50. Subtract. When you plug 2 in, we just said that's -4. Subtract the negative, that's 54. So when I put this together, it's the absolute value of all of this. And it's redundant if it's already a positive number, but it's there, so you see it. So the absolute value added as a positive distance, everything, and you get 58 and the unit. So the total distance the particle went was 58 centimeters. Now F says, find the average velocity. And in your, in the book that you have, there's a box, and it tells you the difference between average velocity and average speed. So average velocity has to do with displacement over time. Well, average speed has to do with the total distance over time. So if I want to find the particle's average velocity, the first thing I need to do is just the displacement. Now, the displacement doesn't matter if it went left or right in between. All that matters for the displacement is where did it end and where did it start. That's all that matters. And you go left, right, doesn't matter. Where did it end? Where did it start? And you subtract over the elapsed time, which is 5 minutes. So we're going to use, and we already did some of that, so x at 5 was 50, subtract 0 over 5, and the average velocity then, 50 divided by 5, right, 10. So it's 10 centimeters per minute. For g, it asks for the average speed from 0 to 5. Now, for the average speed, we need to take the displacement. So we found that up here. So for the average speed, we're going to take 58. So it's 58 divided by 5. And when I do that, I don't even need to simplify it down. If you did simplify it down, 58 divided by 5, 10 point something. Or 11 point something, I should say, 11.6, and that's centimeters per minute. All right, number 6. In number 6, the graph at the right shows the velocity of the function of a particle moving horizontally. So you're looking at a velocity graph. So let's just first understand a velocity graph when we look at it. So this is not the position. So when this velocity graph is above the axes, it's moving to the right. When it's below, it's moving to the left. That's to begin with. Then, when we understand the slopes I'm looking at, that has to do with acceleration. So the negative slope here means the particle is slowing down. Horizontal means it's going at the same speed, meaning it's still moving. It's not stopped. If it was a position graph, that would mean stop. But velocity means it's still moving. It's just moving at the same rate. And again, a positive slope means it's speeding up and then slowing down. But let's just try to see if we understand it. So first of all, when does the particle move left? That's when it's below. So I want you to look there. I need to understand from this point to this point. So I can see it's 7. The other one's a little bit tricky to see. So let's see if we can understand how to find the other one for number 6. So I need to find the slope and equation of this to find what the intercept is. So I can't just say, it kind of looks like a third maybe, a quarter maybe, I don't know. You have to use math to know where that intercept is. This one's pretty simple. The other one is 7. But this one we need to do some linear math first. So one point is at 0, 1. The other point is at 1 and negative 3. So if I did the slope, that's the change in y over the change in x. So negative 3 subtract 1. 1 subtract 0. So the slope is negative 4. So the equation, if we wanted in mx plus b form, would be negative 4x plus 1. That's the equation of that segment. I want the intercept. So I'm going to make it equal to 0, and I'm going to solve it. So if I solve this, I'm going to subtract 1, and then I'm going to divide by negative 4. So if I solve it, what's the exact answer for that value? And the answer is 1/4. So the question is, when is it moving to the left? And the answer is between 1/4 and 7. And notice you could write it that way, or you could write it this way. Both are okay. From 1/4 to 7, it's moving to the left. Exactly at 1/4, it is not. Exactly at 7, it is not. So in between 1/4 and 7, it is below the axis and moving to the left. All right, B. For part B, when is the acceleration positive? So when is the particle's acceleration, positive? So then we're looking at slopes that are positive. So negative, 0, positive slope, just there, from 4 to what number? From 4 to 8. So we're just looking for when it is a positive slope on the graph. And that's from 4 to 8. So again, when we're looking off a velocity graph, where are the slopes that are positive, rising to the right? C, when is the speed the greatest? Now, speed is different when we're looking off the graph. For speed to be the greatest, so speed is the absolute value of velocity. So when I look at that and understand that as being the absolute value of velocity, and I'm going to write that down, speed is the absolute value of velocity. So when I'm looking off the graph to understand that, when I look here as a positive value, the greatest speed is 1. Here too, it's 1. But down here, it's -3. Well, -3 wouldn't seem greater, but because we're talking about speed, it's the absolute value of that. So the absolute value of -3 is +3, and that number is bigger than 1. So where on the graph? So we're looking for either the highest point or the lowest point, and we're reflecting it, if you like, or doing the absolute value of that. So when I'm looking off this graph, when is the speed the greatest? And that's between 1 and 4, because the absolute value of -3 is +3, and that's a bigger number than any of the positive ones. So between 1 and 4. All right, E. No, we didn't. We don't have an E there. So what am I? It says, when is the speed the greatest? That's C. So still all C. Silly me. So speed is the absolute value of velocity. When you look off the graph and take the absolute value of a number and then compare that to the positive numbers, the greatest number was 3, and that was between 1 and 4. All right, part D. When does the particle stop for more than an instant? So know that when the velocity is 0, the particle stops. So right there, the particle stopped, but it only stopped for an instant to change directions. Over here, do you see that between 9 and 10, it has nothing, it has to do with it touching the axes. It's 0, but it's 0 for an extended period of time, not an instant. So from 9 to 10, it stopped for a long period of time, because not just because it's horizontal, but because the value is 0 for a long period of time. And you can do equals to that part. So we're looking to see when the velocity is 0 on the graph, and it's 0 for a longer period of time. So between 9 and 10, the particle stopped for an extended period of time rather than just instantaneously. All right, number 7 will be the last one on this video. The position time, and then I'm going to do the rest on another video. So the position at time t of a pebble dropped from initial height of 600 feet is given. So this is the position of it. So if I want to know the position of the pebble, I can plug in numbers for t to see where it's at. So the first question is, at what time will the pebble hit the ground? So that's when the position is 0. So I can subtract 600. I can divide, and 2 negatives will make that positive. Does 16 go into 600 evenly? I don't think it does. But you're going to have to use your calculator anyways. So it's the square root of 600 divided by 16. And because it's a real situation, it's only the positive answer to that. So the square root of that, so the square root sign is in blue above the x squared. And then if you go control and the divide sign, you get a fraction. And then you just go 600 over 16, and then go Control Enter, and so 3 decimal places. That's 6.124. And we need time. That's in seconds. So just after 6 seconds, it's going to hit the ground. B. For B is, what is the pebble's velocity when it hits the ground? So then we need to find the velocity equation. So the velocity equation is the derivative. So that's 2 times negative 16. Subtract 1 to the exponent. The derivative of 600 is 0. Then we take the answer we just came up with, 6.124, and plug it into there. So if you take 6.124 or 123 and plug it in, what do you get? So negative 32 times 6.124, and you get about negative 195.968, and this is in feet per second. So as it's hitting the ground, that's how fast it's hitting the ground when it hits the ground from 600 feet. Really fast, right? All right, part C, last one to this, and then this part of the video will be done, and I'll do another video on the second half of the assignment. Okay, what is the pebble speed when it hits the ground? Well, that's simply the absolute value of it. So the absolute value of that would mean the speed is positive 195.968 feet per second. So when you have velocity, velocity gives you direction. Negative means it's going down, positive up. When you have speed, you don't have direction. It's just what the speed is. So the absolute value of velocity is speed. So if you have one, you have the other. And there's your answer. All right, Mr. G Math over and out. I'm so proud of you doing your work. And we're going to get this done. The next questions will go a little faster. They are review questions from 8 to 18. That'll be another video. All right, till next time.